Vista stage for supporting us. We're very excited to be here. So I'd like to introduce my esteemed panel of speakers today. I'm going to start with Dr. Nissan. So Dr. Nissan is the Program Quantum Manager in ELTA, which is a division of the Israel Aerospace industry. He previously worked as the CTO of ELTA Cyber Division. And Dr. Maskil has a great deal of experience dealing with quantum technology projects. He led 2 very innovative technology-related projects at the AI Innovation Center, which is run in collaboration with Starburst in Tel Aviv. Dr. Maskil received his PhD in physics from Bar-Ilan University. And that's it. We're going to hear more about him soon. The next panelist I'd like to call Minerbi, the co-founder and CEO of Classiq. Nir is developing a unique platform for quantum algorithm design. He has a history of leading cutting-edge technology, and he has a master's degree in physics, so we have a lot of physics people on the panel tonight. And he's a graduate from the prestigious Starburst program, which is a program in the IDF. He was described by Forbes magazine as a Rhodes Scholarship, a presidential fellowship, and is a Harvard MBA rolled into one. So extremely excited to hear what he has to say. And last but not least, I'd like to introduce Karel Dumon. Karel is the co-founder and the head of the quantum at a company called Miraex. It's based in Switzerland, and they're developing photonic system for industrial sensing and quantum integrated circuits, so they can measure and use distributed quantum computing infrastructure. Karel is also a physics engineer with experience in photonics, material science, machine learning, and quantum computing. Miraex is part of an IBM quantum network and is a graduate of Destruction Lab Quantum Stream, which is the world's first quantum startup accelerator. I hope I got that right, everyone. So we have 3 experts in physics in the panel. So if you want to get into the quantum field one day, guess what you have to study? Physics. So maybe before we start with the questions, I'm just going to give a little bit of context about what we're going to talk today, because quantum is kind of still very much out there. So if you're like, I read about it, I researched it, but there's still a lot of things that we don't know about quantum. So quantum intersects in many areas within the aerospace and defense industry, right? We try to make the content very focused to the audience. So if we take space, for example, we live in this increasingly connected society, and we are relying on satellites and more broadly in space, and it's crucial for the functioning of our daily life. The limitation and the challenge which the current generations of technologies are facing to invest more in promising emerging technologies. So quantum tech, when it comes to space, you have quantum communications, you have quantum simulations, quantum computing, you have something called quantum metrology, which we're going to talk about, and you have quantum sensing. And then if you look at it from the military standpoint, a lot of the quantum techs are dual-use technology, and they are used for the interest of the defense and security industry. More specifically, they use quantum key distribution, or QKD. They use it for quantum cryptanalysis, for quantum sensing, and these 3 areas all have promising application for the strategic security of the country. For example, QKD will provide a near-term advantage for defenders to secure their communications, while quantum cryptanalysis is an inherently offensive capability, though it's maturing at a slow pace. So now that we all are on the same base, more or less, we're going to start with our first questions, which I'm going to turn to Nir from Classiq. Nir, could you describe the quantum computing revolution in the aerospace and defense industry, and how it affects the companies in that space? A bit closer to the mic so they can all hear you.
Yeah. So quantum computing is being discussed since the 80s, right? And it was pretty clear that once someone succeeds to deliver a quantum computer, it will be a revolution, right? But only the last 5 or 4 years, it shifts from a dream to reality. And this revolution has two main parts. The hardware, and this endeavor is led by the tech giants, by Google, Intel, IBM, Microsoft, Amazon, governments, and the hardware is getting better every year. The magnitude of these computers, the capabilities, and this is very good news because someone in the coming years will be able to bring advantage that we can bring even with the most powerful supercomputers. And the other part of this revolution is the software and the end users, and we see many enterprises in various fields, in aerospace, in defense, in finance, in automotive, in chemistry, and so on, getting into this field, establishing quantum algorithm teams, quantum software teams, and trying to develop today the game-changing algorithms of tomorrow. And in the next coming years, they will bring great advantage in various revolutionary use cases.
Thank you. So my next question touches upon, it's for Karel. And Karel, what do you think makes quantum technology so efficient and potentially useful in aerospace?
Thank you, Minerbi, for the question.
Closer, Karel.
That's better. I think Neil made a good point, and the question also highlights a bit where we are today. We are not talking about quantum science only, but also about technology and engineering. Because in the last century there was a lot of new fundamental discoveries, but now we are at a stage in the second quantum revolution where we can really use quantum objects and to make new technologies and new applications. And mostly in three areas. So we have computing, as Neil said, we have a fundamental new paradigm of computing where we can calculate things previously uncomputable. Next to that, you have communication, for example, QKD, quantum key distribution, where we actually use fundamental laws of nature to make things encrypted and you cannot hack it anymore. And then the third part where you have new technologies, sensing, metrology, where what we are doing, for example, with our quantum transducers, we bring superior sensitivity and compactness to fields, where in sensitivity you are really using quantum resources to make more precise measurements of the objects you want to measure. For example, entanglement for breaking classical limits of sensing, or you're using single quantum objects like photons to make new schemes. And in terms of compactness, which is sometimes not highlighted, but most quantum technologies use micro-scale level technologies, which can bring better spatial resolution, but also you can integrate them very well with existing platforms.
Thank you, Karel. I hope you are taking notes. There will be a quiz at the end of the panel. My next question is for Dr. Nissan Maskil. So we're going to zoom out a little bit and try to understand from him, Nissan, what quantum technologies and trends are being used the most within the aerospace industry? That's the first question. And the second is, what do you think is the biggest challenge to incorporating quantum technology in the aerospace industry?
Thank you for the introduction. You guys cover the most important field that are invested in technology of the quantum. This is the basic blocks that enable to enhance all the component in the avionics. When we are speaking about avionics, we are speaking about the production, the industry process, we are speaking about sensing, airport materials, different kind of avionics system, and even calculation of performance of the. In each one of them, no doubt, quantum will enhance the performance. And we are in the stage that we are speaking about the engineering phase. After understanding the physics capability, engineering need investment. And now we see that the most advanced field is the computer because the advantage came out of the huge budgets of investment in the computer, in quantum computers. But the sensing enable to move all the performance of the avionics.
What about the challenge?
And the challenge is to transfer the physics to engineering, to technology. We are doing, and I understand there are many places in the world in order to product quantum elements. And this is a huge challenge because part of it is in low temperature and the production and development is very scientific challenge. So I believe that in 5-10 years, all the products that we need in the world in avionics will include quantum elements, quantum performance. Thank you.
So my next question goes back to Nir. Nir, Classiq, your company that you co-founded, is working with a lot of aerospace and defense companies in co-development solutions, including AI and Nissan. What would you advise to other aerospace companies that have no quantum computing activities, but they want to be ready for this exciting future? What should they be doing now?
Yeah, so my best advice would be just do it, right? It's not too late, it's definitely not too early, and this is the time to establish these small quantum teams. No, it doesn't have to be, you don't need to bring like 20 quantum information PhDs. You need one person who has some quantum knowledge, and many people in the company who have your domain specific knowledge, right? Whether it's in, aerospace or cybersecurity or anything like that, they know what they want to design, and now they can do that with quantum computers. So you need to be prepared, you need to understand what are the use cases, you need to find the right partner, and you should probably do that now.
Or they can partner with you guys or with Miraex, right? You're open for co-development solutions.
Yes, we do.
All right, so don't be shy. Feel free to, if you don't have a quantum lab, reach out to Nir or to Karel and talk to them about it. My next question is for you, Karel. So currently at Miraex, you guys are developing quantum-enhanced sensors, and those sensors have unprecedented sensitivities that you use for radar, satellite communications, but also photonic sensors. So my question is, how do quantum sensors enhance current sensing capability? And what aspect of defense do you think they're going to revolutionize or have the greatest impact on the near future?
Alright, so it's a multifolded question, I would say. So indeed, I tried to highlight it already a bit before, but in terms of the three areas where quantum is going to revolutionize, sensing is actually very advanced. I mean, quantum computing makes a lot of noise in terms of marketing, but and especially in Europe, where we are from, we are very advanced in quantum sensing. And what we do specifically, so we say quantum enhanced, so indeed it's we focus, and we are very good at Miraex at converting microwave to optical. So microwave is a certain region of electromagnetic radiation, which has a lot of applications in the defense already. We have radar, etc. But there are also some issues. Microwave photons, they are very low in energy, so they are very hard to detect, but also very fragile. Like in quantum computers today, we have single microwave photons living there, but they have to be cooled and have to be shielded. But on the other side of the spectrum, literally, you have optical frequencies, which is already very advanced today. The whole internet, the backbone of the internet is by telecom, which is using optical fibers, very robust, very high in energy. You can, the optical photo can live at room temperature. So we actually want to bring the optical technologies to the microwave world, and especially in defense, this has a lot of applications like in radar. So, for example, we can detect single photons, but also have other engineering advantages, like because you're using optical after the antenna, you're not susceptible to electromagnetic blast, for example. But also we have better accuracy, because, for example, in optical technologies today, we are doing the most precise measurements in the world, like gravitational waves are detected using optical interferometers, but also distance to the moon with this optical technology. So we try to bring this to the microwave domain to enable also quantum technologies there. And just to add on top of that, a bit like Nissan said as well, in the next 5 to 10 years you will see a lot of quantum technology coming to the real world. But it's not only manifested with quantum properties, because for example we as well, we are making also classical sensors which are inspired on the quantum technology we have. And also maybe in terms of prices it's a bit cheaper because you're using existing manufacturing technologies, whereas for quantum projects it can be a huge engineering challenge. But like a sensing system which uses some of the quantum technology in the classical world, you can already have for 5,000 euros at the end of the day. This is what we do.
Thank you, Karel. So I see there's many different applications, not just space, not just defense.
Yeah, for
touch
sure.
about everything. My next question is for Dr. Nissan Maskil. We're going to deep dive into the quantum metrology, which is the study of making high resolution and highly sensitive measurements that uses quantum theory to describe the physical system. And obviously we're going to look at it as it's relevant to the aerospace and defense. And Nissan, has it found any application in the industry needs other than aerospace? And what's your take on metrology sensors?
Yes, the benefit of quantum revolution, the second quantum revolution, is enhancing the performance of sensing, and there is a lot of initial concept compounds of high sensitivity and using single photon detection in order to enhance the performance of system for avionics. The capability will enhance the resolution of distance between aircraft, the resolution of measurement, all the performance of the aircraft. In addition, the maintenance performance of aircraft will be enhanced using high fidelity second evolution components. Another field that's just in the beginning is the enhancement of the resolution. The resolution, which is very crucial in order to track avionics, will be enhanced by using quantum capabilities, quantum enhancing of sensors and computation performance. So, to summarize, we can say that we are just in the beginning of understanding the second evolution components, performance in avionics. Thank you.
Thank you, Nissan. So now that we understand a little bit more what is quantum, I know it's a deep, deep subject, so I don't expect all of you guys to be expert by the end of the panel, but the point was just to give an introduction on how it affects the aerospace industry. We're going to look at the future. So Nir, my next question is for you. And we already touched upon a little bit before, but maybe we can elaborate more. What does the aerospace and defense company need to do today in order for them to be ready for the next quantum computing revolution that Nissan just mentioned? Concretely.
Sure, so maybe we'll discuss some of the interesting use cases. So basically the first rule is if a problem is not a hard computational problem, you just don't need a quantum computer, right? Quantum computers are good where classical computers choke. So luckily, or unfortunately, it's up to you guys. So in the aerospace industry, we have a lot of hard computational problems, right? Monte Carlo simulations and material science and fluid dynamics and cybersecurity and optimization problems, right? Scheduling and other types of optimization problems. Basically, what we are doing today is, having our HPCs struggling to solve this problem in a very suboptimal way. And this is exactly the places where quantum computers will be able to bring huge advantages. right? With some of the use cases, it could happen in the next couple of years with few hundreds or few thousand qubits provided by IBM and Google and Amazon and so on. And some of the use cases are longer term, but this is the right time to understand what are the use cases, how could they improve and support our R&D, and be ready. It's coming pretty fast.
All right, be ready goes
I
back.
just want to add to this.
Sure.
We have to understand the use cases will be, in most of the cases, totally different from the current use cases that we are doing in the classic computational performance. So it's another way of thinking toward achieving use cases, and this is the most advanced evolution.
And we don't know yet what they will be.
We know only partial of this, not all of them.
We
This
gotta
is
be
not-
comfortable with uncertainty.
Correct,
Like it's true
correct,
life for them.
correct.
Okay.
So this is the big way, the new way to start.
So Karel, my next question is for you. Did you guys know that there's such a thing called like quantum internet, which Miraex is also developing through the quantum converters? And quantum internet is basically a network that is enabling quantum communication among remote quantum nodes. Very exciting. So my question, Karel, is what are the disruptive functionalities of this quantum internet for the aerospace and defense?
All right. Just also, you just said no. We now understand quantum, but don't worry if you don't understand, because some of the most famous physicists said this as well. If you think you understand, you're probably doing it wrong. So quantum internet. So now we are really talking about the far future, right? Because this is somehow the moonshot for quantum technologies in general. Because the concept of quantum internet is like we have the classical internet today, is to connect all quantum objects together in one quantum coherent way. That's using quantum a lot in one sentence, but okay. Meaning that all areas of quantum which have been discussed, computing, communication, sensing, they will be merged into one. So for example, in terms of applications, you would be, for example, sensors will be connected to quantum computers, to quantum memories, and applications there could be that you have new kind of sensing schemes that Nissan said. You have to think beyond the classical schemes you have today. So this could be distributed quantum sensing using sensors like we have in the classical internet today. You connect them all together. This could be using quantum computing resources to enhance your sensing scheme. Now switching a bit to computing, what could it bring there? I think there it's probably the most near-term application for quantum internet. It's really having a local distributed quantum computing cluster, and this is what we bring in the closest term with Miraex as well. We want to connect different quantum processing units together, just as you have in the classical data center today. And I think that this is overlooked a lot in general talks about quantum computing, but in the last year you see it more and more, and Google and IBM, they are talking about it. They are facing a lot of hurdles. They think in 10 years they have 1 million qubits, but when they are now publishing their roadmaps for how to get there, one of the steps there is to make modular quantum processors. And with our quantum converters, this is exactly what we try to enable. As I said before, we convert microwave to optical, so we put an optical fiber cable between the different quantum processors, just like in a classical data center today, but then we try to connect them in a quantum manner. And this is like a new dimension to scale quantum computers to real-life practical sizes for practical applications. And one last thing, I've left out a bit the communication field, but also there, for example, with a quantum converter for quantum computers, we could, if this works well, we want to use this to make quantum repeaters, because like in China and also, like for example in Switzerland, we have quantum networks already, but in the end they are node-to-node, so direct node connections. But if you want to go beyond one node, which is how the network, the internet, classical internet works today, you need what is called a quantum repeater. And this is probably one of the most advanced things you can make, because today there are repeaters, but they are trusted nodes, meaning you can still hack into them. Like in China, they have a network of maybe 20, 30 nodes. But imagine you could hack into the trusted node, you're still, your quantum network is hackable again. So if you would have a quantum repeater, you are now going very advanced. You can distribute entanglement across the whole globe. So you can imagine connecting a quantum computer from IBM in Zurich with a quantum computer in San Francisco with Google across this backbone which is distributed across the globe.
Karel, do you think in a few years we'll have an iPhone powered by quantum internet? Is that
well, this is a good question actually, because I can go into the two extremes. I can say no, for sure, the chip in your iPhone or Samsung phone or whatever, it's still going to be a classical, as Leo said, for the things you can do already today. You don't need an alternative. But on the other side, and also I think quantum internet is maybe not necessary for applications today. But actually, Samsung has a quantum chip in one of their phones already today.
Oh wow, it's already here.
It's developed by ID Quantique, which is a Swiss company. The founder of that is in our board, so we are a good company. He sold his company or part of it to SK Telecom, so South Korean telecom. And now Samsung, so you can buy in Korea a phone with a quantum random number generator chip inside, meaning so today classical random numbers are pseudo-random, so in the end if you know the code behind you can hack it. But quantum can provide real randomness, and in the end this sounds a bit weird, but today there is no source which can provide a real random number to you. But then, so you see already today in some unexpected way quantum technologies are coming to the market. And I think even if it's not a real quantum processor in your phone, I think for sure there will be a technology that's spin out of it towards classical applications.
I can't wait. That'll be a good reason to upgrade the iPhone, the quantum chip. So you talk a lot about hacking potential quantum networks. So my next question is for you, Nissan. When do you think that the quantum computers will be able to break our currently encryption methods, if at all? And what does our audience and anybody listening could be doing now to future-proof our system to make it unhackable?
I don't know when, but I'm sure that in the next future, I mean in a couple of years, short,
like 5 years, 10 years, try to give us
5 years, the use of quantum limited capability will be used for avionics, and we can imagine the use cases that will enable superiority in performance for avionics, and that's something that can be built with a small-scale computer, as we call it, the hybrid concept of quantum computer, that will enable use for different maintenance and performance capability in enhancing resolution and planning. And this is something that we believe is coming soon, very early, much earlier than we can dream about.
All right. So I'm sure these guys could keep talking about quantum for hours and hours. As you can see, they're passionate about what they're doing, but all good things must come to an end. So that was the end of our panel. I want a warm round of applause to thank our panelists for coming all this way. They will be around and available for additional questions in the Vista Lounge over there. But stick around because we have more good things coming with a series of startup pitches. So I will put the mic back to you.
No, 100%. Give them a big one.